Hello and welcome back, Math 140 students. This is our last section of the semester. This is it. This is the last thing you guys need to know in order to move on from Math 140. So, section 12.4, we are solving systems of nonlinear inequalities. So we want to determine whether an ordered pair is a solution of a system of linear inequalities. So the example below, it says, does the ordered pair -5, 5 satisfy the following system of inequalities? So what we can do is we are going to plug in these values to see if it makes it true or false. So here's my x value and there is my y value. So let's go ahead and think about that first equation. So we have that -6x plus 4y is greater than or equal to a positive 6. So we want to know if we plug in the ordered pair -5, 5 for my x and my y, is this going to be a true statement or a false statement? So I'm going to go ahead and plug in these values and see what I get. I'm going to put a question mark because I'm not sure if it's going to be true or not. So the x value that I'm plugging in is a -5, and the y value that I'm plugging in is going to be a positive 5. So if I bring up my calculator, let's see. I have -6 and I have times a -5, and it says plus 4 times 5. I get that side to be 50. So it's 50 greater than or equal to 6. Is that true? Is 50 greater than or equal to 6? That is true. So far, so good. Now, let's try it in my second equation. I have y greater than or equal to a 3x over 4 minus 2. So I have y greater than or equal to 3 over 4 minus 2. And again, I am using that -5, 5 for my x and my y value. So the y value that I'm plugging in is 5, and the x value that I'm plugging in is a -5. So we do not know if this is true or not. This is what we're trying to figure out. Is 5 going to be greater than or equal to a -15 over 4 minus 2? And what is a -15 divided by 4? So that's a -3.75, and don't forget to subtract 2. So I have a -5.75. So is 5 greater than or equal to a -5.75? Well, any positive number is bigger than any negative number. So this is true. So we can say that 5 -5, comma 5 is a solution. Okay. So it satisfies the system of equations. So you can also say yes. Okay, so we're going to do the exact same thing for this system as well. So we're just plugging in values. So you're just like, okay, so for that first one, I'm going to go ahead and write it out. I have a -3x minus a 5y less than -3. And the ordered pair that I'm trying out is when x is equal to -2 and y is equal to a -5. So I'm going to go ahead and plug that in. So I have a -3 minus 5 less than -3. So if I plug in my values accordingly, the x value is a -2 and that y value is a -5. And this is a question mark. I'm not sure if this is true or not. So let's see if it's going to be true. So I have -3 parentheses -2 close the parentheses, minus 5 times negative 5. So when I plug that all into my calculator, I'm going to get a positive 31. So is this statement true? Is 31 less than negative 3? No. 31 is not less than negative 3. That cannot be true. So we're going to say no. Negative 2, negative 5 does not satisfy the system. Not true. Okay. And for the next one, now we're going to be actually graphing them. So here I had a bit of a typo. I apologize. It looks like there's an equal sign, but it really should be a plus. So x plus 4y less than negative 16. So if I were to look at that, then I know this is linear. So I want to get it into the y is equal to mx plus b, where b is my y-intercept. It has the ordered pair 0, comma b. And I know that m is equal to my slope, where I have my rise over my run. Okay? So I want to make sure that I get this into the y equals mx plus b form. So I'm going to subtract x from both sides. That gives me a 4y is less than a negative x minus 16. So now I divide every little piece by 4. So that I'm going to get y is less than a negative 1/4 x minus, and if I have 16 divided by 4, that should give me 4. And because of the way that this looks, it's going to be a dashed line. So I have my y-intercept at negative 4. And my slope is negative 1 over 4. So I'm going to go down 1 to the right 4. Also could have gone up 1 to the left 4. And so my graph, more or less, looks something like that. And don't forget, you're going to be shading. So y is less than, so I'm going to shade below. So if I'm shading below, and remember, this is kind of where you do the cheese and pepperoni. So let's say this one, I'm going to have my cheese. So if I have cheese, that's what my cheese looks like. And I used this example earlier in the semester. So I'm not fully shading it in yet. I just know that it's shaded in that direction since it's less than. Now I'm going to be dealing with my other equation. So for my other equation, I have this 2x plus y greater than or equal to 1. So I am going to subtract 2x from both sides. That's going to get me that y is greater than or equal to a negative 2x plus 1. So that means my y-intercept's at positive 1. My slope is negative 2 to the right 1. Or I could have gone up 2 to the left 1. And this is going to be solid. And it's a solid line because there's a line underneath inequality, so it's greater than or equal to. And this is y is greater than. So I'm going to be shading above. So from that blue line, I'm going to have my pepperonis. So where's my slice of pizza that has pepperoni and cheese? Well, that is going to be where it's both blue and purple. So the only place where it's blue and purple is going to be in here. So this is actually my solution set. That little corner in there. Okay, well, I hope that is a friendly reminder of how to graph inequalities. So now we have applications, which means it's going to be the word problems. So let's see what this says. It says, Grandpa and Grandma are treating their family to the movies. Matinee tickets cost $4 per child and $4 per adult. Evening tickets cost $6 per child and $8 per adult. They plan on spending no more than $80 on the matinee and no more than $100 on the evening tickets. Let C represent the number of children they will take to both shows, and let A represent the number of adults they take to both shows. Write the system of inequalities to model the situation. So, okay, so they don't even want you to solve. They just want you to write the model. So you're just like, okay, well, it tells us that they want C to be the children. So, okay, so C is going to represent the cost or the amount of children that they're going to be taking. And then it also says that A represents the number of adults they take to both shows. So, okay, so A is going to equal to my adults. So it's the number of children for C and the number of adults for A. Now, let's keep reading here. So I'm going to have two equations. It says, for the first one, that matinee tickets cost $4 per child and $4 per adult. So 4 per child, well, it's 4 times my child, which is 4C. And I have 4 times my adult, which is 4 times my A. And it says that they plan on spending no more than $80 on the matinee tickets. So no more means it has to be less than or equal to 80. So that's going to be my first equation, that 4C plus 4A, so 4 children and 4 adults, so $4 per child, $4 per adult cannot cost more than $80. So it has to be less than or equal to $80. Now let's worry about that second part. It says that for the evening tickets, it costs $6 per child. So $6 per child, that would be 6C. And $8 per adult, well, that would be my 8A. And the evening, since I'm talking about evening, cannot cost more than $100. So it has to be less than or equal to $100. So my second equation is $6 per child ticket plus $8 for adult tickets has to be less than or equal to 100. So let's see what that is going to look like. So I have 4C plus 4A less than or equal to 80, and I have 6C plus 8A greater than or equal to 100. So that's not going to be it. So then I have 4C plus 4A less than or equal to 80, 6C plus 8A is less than or equal to 100. So this one looks about right. And they're both kind of facing the same way. So this is going to be the equation. Okay. And that is the last example I'm going to go over for Math 140 for spring semester. Okay, I hope you guys have had a wonderful time. I've enjoyed my lectures with you. And if you guys have any questions, please feel free to email me or contact the Math Success Center for more help. Thank you.